Good afternoon. We will start our lecture now. So, yung topic natin for today is about doubly-reinforced beams, wherein we will tackle about the importance ng doubly-reinforced beams dito sa sa actual field natin, and at the same time we will tackle on the derivation processes ng uh, kung paano ba mag-analyze or design ng doubly reinforced beams. So ngayon, ano ba yung importance ng doubly reinforced beams? Karaniwan kasi ng mga design natin sa actual field, nagkakaroon ng mga variations, kumbaga, na minsan hindi natin ina-expect na kung ano yung gusto ng architect would be syempre, of course, designed by an engineer pagdating sa structural integrity. Ngayon, syempre, kung hindi kaya nung actual na dimensions yung reinforcement na pinopropose mo doon sa structure mo, meaning to say, kailangan mo ng ways para ma-mitigate kung ano man yung magiging probable error. So karaniwan ng design natin, 'di ba? Ina-assume natin or ina-assure natin lagi na dapat singly reinforced siya. Kaso nga, kung halimbawang long span yung gusto ng architect mo or mahaba yung unsupported length niya, kumbaga parang gusto niya ng beam na around 8 meters, ganyan, pero bawal ang column in between. So, saan ka po pwedeng tumingin? Titingin ka ngayon sa amount of reinforcement na dapat mong ilagay. Ngayon, necessary na maglagay ka ng compressive reinforcement. Let's say, for example, meron tayong RC beam na siyempre, karaniwan ng mga beams natin, kung makikita natin, yung mga reinforcement niya, di ba, kapag nagde-design tayo ng singly, ina-assume lang natin na merong bakal doon sa tensile part ng beam mo. Pero syempre, yung mag-hold ng stirrups mo, kailangan din ng bakal. So meaning to say, basically, lahat ng mga dinedesign natin, either singly or doubly, nagfo-fall pa rin siya under doubly reinforced because meron kang holder ng stirrups. Diba? Let's say ito yung tension. And then, syempre, doon sa taas natin, alam natin na nandito yung compressive part. Diba? Ngayon, dito sa case natin ng reinforcement condition, nangyayari minsan na or parate na kapag nagde-design tayo, lagi tayong may nilalagay na stirrup support. So yung support ng stirrups na yan can also become your compressive reinforcement. Meaning to say, yung dinedesign natin na may ultimate moment capacity in tension, po pwede pang tumaas kung meron tayong compressive reinforcement. So lahat ng ginagawa natin dito by theory, nadadagdagan siya at some point sa actual. Ngayon, bakit kailangan mong maglagay ng doubly reinforced beam? Or bakit mo kailangan maglagay ng another compressive reinforcement? So, bukod sa stirrup support and architectural requirements, kailangan mo rin yung doubly reinforced beam kung may seismic requirements kang kino-consider. So, yung seismic requirements na kino-consider natin, yan naman talaga yung kailangan natin gawin para ma-ensure natin na yung building natin or yung structure natin is can resist yung mga natural conditions na pwedeng mag-occur doon sa area niya. Same time, yung need for torsion and deep beams. Kasi minsan, yung mga long span, siyempre, kumbaga parang kapag nag-design ka, let's say, ang span mo ay around 8 meters, ano ba yung napapansin natin doon sa dimension ng beams? So doon sa dimension ng beams, nakikita natin na kapag lumalalim yung beam natin, mas lumalaki yung capacity. Kaya kailangan laging malaki yung effective depth kumpara doon sa base. So, mas malalim yung beam, mas malaki yung pwede niyang i-carry na moment or pwedeng i-carry na force. Bakit? Kapag lumalaki yung effective depth mo, ano yung pwedeng lumaki? Pwede rin lumaki at some point yung, okay, effective depth ulit is yung depth mula sa reinforcement mo hanggang doon sa compressive fiber. Kapag lumalaki yung effective depth mo, may chances din na humahaba yung moment arm. Diba? Ang moment arm natin is equated as Z or equal to D minus A over 2. Meaning to say, kapag lumalalim yung beam mo, lumalaki yung effective depth. Kapag malaki yung effective depth mo, malaki rin yung moment arm mo. Kasi alam natin na yung moment mo is equal to the force na either compression or tension multiplied by the moment arm. So need yung compressive reinforcement kung lumalalim na yung beam mo. Kasi hindi rin natin ma-ensure kung up until when magkakaroon ng crack doon sa tensile part mo ng concrete. Or kung yung compressive part natin ng concrete is mag-fail. Kaya, requirement din siya in terms of stiffness and ductility. Kasi hindi natin din ma-ensure na matibay yung nasa compressive part mo. Ngayon, within the compressive part, kung compression ng concrete ang pag-uusapan natin, merong chances na magkaroon ng cracking doon sa concrete once ma-experience na niya yung utilized part niya. So meaning to say, kailangan nating mag-compensate ulit ng another compression ng steel para maiwasan natin yung cracking ng concrete. So yun yung reason kung bakit kailangan natin ng doubly-reinforced na beam. So another thing is, syempre kung meron tayong idadagdag na element doon sa beam natin, definitely kailangan din ng another resisting force. So meaning to say, bukod doon sa tension ng steel, kailangan din nating i-consider ngayon yung compression ng steel as a requirement para makuha yung allowable capacity ng beam natin. Question so far?
Wala naman po, sir.
Wala pa. Okay? So, paano ba tayo ngayon magsosolve ng doubly-reinforced beams? So, kapag magsosolve tayo ng doubly-reinforced beams, ganito yung nangyayari. So, kapag meron tayong doubly-reinforced beam, meron tayo ulit kino-consider na concrete beam wherein subject siya sa either compression or tension. Given na meron tayong compressive reinforcement doon sa itaas or doon sa area ng compression and tensile reinforcement doon sa area in tension. Now, alam natin na from the neutral axis, hindi dyan ngayon magfo-fall yung compression natin. Ang compression natin would be 85% ng buong compressive block. Same time na meron tayong tensile reinforcement. Ngayon, itong kino-consider natin dito sa taas would be the compression of concrete. Wherein yung compression ng concrete is equal to, kung nag-a-assume tayo ng singly reinforced beam, ano ulit yung compression ng concrete?
0.85
0.85
F prime C A B po.
F prime C A B. So yan ngayon, yung compression ng concrete. So mag-start tayo dito sa taas na meron tayong area for compression ng concrete. Next. Ngayon, since meron tayong compression ng concrete, ang pwede nating gawin this time is to determine kung ano ba yung compression ng steel. Ngayon, bukod doon sa compression ng concrete, meron na tayong kino-consider in terms of compression ng reinforcing steel natin. Given na meron tayong compressive reinforcement na equal to A prime S. Ngayon, yung compression ng steel, hindi rin siya lumayo doon sa tension ng steel. Because yung area ng steel reinforcement natin is only the indicator na iyon yung area kung saan init yung yield strength ng steel natin. Ibig sabihin lang nun, yung compression ng steel ngayon is equal to ano? Kung parehas lang sila ng tensile force in terms of theory, ang compression ng steel ngayon is equal to the area of compressive reinforcement or A prime S multiplied by Fy. So, ibig sabihin, kumpleto na ngayon yung compressive part natin. Ngayon, for every moment na present dito sa system natin, nagkakaroon din ng time na dapat yung compression may tandem na tension. So, yung tandem na tension natin, dun sa dalawang part natin, ay hindi parehas. Bakit ngayon hindi parehas yung dalawang tension? Ano yung alam natin sa couple forces? Yung couple forces ay separated by a distance, covering different directions, but ano yung importante sa couple forces? Bukod doon sa dalawang sinabi ko.
Same magnitude po.
Same magnitude. Okay. So doon sa same magnitude, ibig sabihin itong T1 is equivalent doon sa compression ng concrete, whereas T2 is synonymous with the compression of steel. Ibig sabihin yung T1 natin is equal to a specific area ng tensile reinforcement, which is AS1, Fy, and yung T2 natin is AS2, Fy. Take note na kapag may prime ulit sa variable natin, this is denoted as compression. Okay? So, yan. Kapag may prime, compression yan. Kapag walang prime doon sa variable natin, meaning to say, tension yung variables natin. Okay. Ngayon, parehas na present na yung both compression and tension, paano natin ngayon maka-convert itong dalawang forces na to into moment? So, makakakita kayo ngayon ng hint na yung moment, yung nominal moment capacity within this specific beam is equal to the nominal moment capacity in terms of compression of concrete plus the nominal moment in terms of the compression of steel. Paano natin ngayon gagawing nominal moment itong dalawa? So, dito sa nominal moment na in terms of compression of concrete, meron tayong idea kung paano siya gagawin. Yung idea na gagawin natin is just the same as that of the singly reinforced beam wherein meron siyang moment arm na Z1 wherein Z1 is equal to ano ulit yung depth ng compressive block natin? Yan.
A po.
Yan yung value ng A or yung fictitious depth ng compressive block natin. So meaning to say, yung moment arm natin na Z1 is equal to the effective depth D. So yung D ulit is galing doon sa compressive fiber hanggang doon sa steel reinforcement. Meaning to say, Z1 is equal to D minus A over 2. Ngayon, alam natin to basically kasi yung singly reinforced beam ay natakal na natin last time. Ngayon, paano natin ngayon makukuha yung nandito sa compression ng steel? Ano yung alam nating distance mula doon sa centroid ng compressive reinforcement hanggang doon sa compressive fiber? Okay, ito ulit. Mula doon sa centroid ng compressive reinforcement mo hanggang dito sa compressive fiber. Yung pinakataas ng beam or yung soffit.
Concrete cover, sir.
Yung concrete cover, di ba? So yung concrete cover natin, can also be considered as the effective depth of compressive reinforcement na tinatawag natin na D'. So this is effective depth of compressive reinforcement. Ibig sabihin, yung moment arm natin na Z2 is equal to, ano na ngayon? Yung effective depth minus yung effective depth of compressive reinforcement na D' or yung concrete cover. Questions dito sa derivation natin so far? Malinaw?
Sir, ako po may question.
Okay, question.
Yung sa ano po, compressions, ay yung steel po dun sa may compression, di ba po yung formula niya is A prime S times Fy. Lagi po bang i-consider na Fy po yung ano niya, yung sa formula? Kasi po, di ba po kapag Fy, ibig sabihin nag-yield yung bakal. Lagi po ba siya i-consider na nag-yield or may times po na hindi po nag-yield yung nasa taas?
Okay. So may times na hindi nag-yield yung nasa itaas. Katulad lang din ng nasa tension part natin na kapag hindi nag-yield yung bakal natin in terms of Fy, kailangan din natin siyang palitan in terms of Fs. May times na nangyayari yon. So hindi natin magagaranty na mag-yield yung compressive reinforcement. Kaya kailangan natin nire-resolve yung Fy if ever na, or kailangan natin i-prove muna na nag-yield yung steel natin before anything else.
Okay po, thank you po.
Okay. Questions pa? Okay. So, walang question so far. Ngayon, ang gagawin natin next is, kung kumpleto na tayo ng forces and ng moment arm, pwede na natin ngayon malaman kung ano ba yung equivalent na internal moment capacity. So yung Mn natin na total should be equal to what now? Meron tayong compression ng concrete and tension ng steel. Pero yung tension ng steel natin is fractional. Kung mapapansin natin din, yung AS1 or yung AS natin na tensile reinforcement can be equal to AS1 plus AS2. So ibig sabihin, medyo mahirap yung part na kailangan pa natin isolve yung AS1 and AS2 para lang makakuha ng nominal moment, di ba? So ibig sabihin, pwede nating gamitin yung compression ng concrete and yung compression ng steel as a reference para makuha yung nominal moment capacity ng concrete beam natin. Now, ano yung mapapansin muna natin dito sa CS and T2? Nasabi kanina na yung couple forces daw ay equal in magnitude but differs in direction. So meaning to say, yung AS2 natin can also be equal to given na CS is equal to T2. Yung AS2 natin can be equivalent to AS or ano yung equivalent na AS2? Kung yung CS is equal to T2. Ibig sabihin lang ng CS is equal to T2, meron tayong A prime S Fy is equal to AS2 Fy. Canceling both sides, meaning to say, yung AS2 natin is also equal to A prime S. So, ibig sabihin, any amount of compressive reinforcement would constitute the value of T2. Diba? Ngayon, mas madali nating pwedeng kuhanin yung nominal moment. Now, yung nominal moment natin is now equal to meron tayong 0.85 or meron tayong compression ng concrete multiplied by Z1 plus compression ng steel multiplied by Z2 or equal to 0.85 F prime C AB multiplied by D minus A over 2 plus yung compression ng steel natin which is equal to A prime S Fy multiplied by D minus D prime. Yan ngayon yung nominal moment capacity ng buong concrete beam natin. Which means that the ultimate moment Mu is equal to the strength reduction factor multiplied by the nominal moment. Ngayon, sir, paano natin hahanapin yung strength reduction factor? Yung strength reduction factor, sir, dependent sa value ng Fs. Diba? Ngayon, yung value ng Fs natin ay nakadepende or yung value ng strength reduction factor natin ay dependent doon sa tension or tensile reinforcement ng concrete beam natin. Ngayon, bukod dito sa nominal moment na kino-consider natin, ano pa yung pwede nating mahanap dyan? Yung critical dito is, hindi natin alam kung ano yung value ng A. In this way, paano natin ngayon hahanapin yung A? So, bukod doon sa nominal moment, pwede nating i-consider yung value ng A. To solve for the value of A, we need to assume that the compressive force is also equal to the tensile force. So, ibig sabihin, sa doubly-reinforced beam, ang summation ng compression is also equal to the summation of the tensile forces. Meaning to say, lahat ng compression natin sa isang side, which is equal to 0.85 F prime C AB plus A prime S Fy is equal to ano yung tension ngayon. Yung summation ng tensile forces natin is equal to AS1 FY plus AS2 FY. Ibig sabihin, merong common term yung nandoon sa tensile part natin. Na pwede rin nating sabihin na this is equal to AS1 plus AS2 multiplied by FY. Ano yung mapapansin natin doon sa AS1 plus AS2? Doon sa AS1 and AS2, yan. Context clues. Kapag kinonsider natin yung AS1 and AS2, ano yung magiging resulting reinforcement niya? Ito ngayon yung ano? Sige, punta ulit tayo dito sa figure. Now, kapag pinag-add natin yung AS1 and AS2, ano ngayon yung mabubuo ng dalawang reinforcement na yan? Yung ano ulit? Naririnig ko na yung answer kanina.
AS po was
Yung buong AS. Diba? Ibig sabihin, yung summation and tension pa rin would remain the same na nandoon sa original system ng ano na, ng tension natin. Meaning to say, 0.85 F prime C AB plus A prime S Fy is equal to AS Fy. Ngayon, syempre kung doubly reinforced yung beam natin, ibig sabihin, iba rin yung value ng A. Originally, yung value ng A natin sa singly, yung value ng A is equal to AS Fy all over 0.85 F prime C B. Pero kung doubly ngayon, yung reinforcement natin, ang value ng A now would be equal to no,
AS prime FY. AS FY minus AS prime A prime S FY over 0.85.
0.85 F prime C B. Or, kung simplified yung term natin, pwede natin sabihin ngayon na yung value ng A is equal to AS minus A prime S Fy all over 0.85 F prime C B. Yan na ngayon yung value ng A natin. Of course, yung value ng C natin would remain the same for singly and doubly, wherein value of C is equal to A all over beta 1. Kasi alam natin na yung value ng A is also equal to beta 1 C. Questions so far?
Wala naman po.
Wala naman. Okay. So, given na meron na tayong value ng C, so kung process-wise, ang kino-consider natin, sa paghanap ng value ng C, meron din tayong makukuha dyan. So let's say, sketch ulit natin yung concrete beam natin. So meron tayong tensile reinforcement. Same time, meron din tayong compressive reinforcement. Ito yung neutral axis natin. And then, some point, in terms of strain, okay, punta tayo sa net tensile strain. Kung strain ang pag-uusapan natin, alam natin na ang maximum strain ng concrete is equal to 0.00 ano?
3 po.
3. Di ba? Ngayon, yung strain na kino-consider natin sa concrete, and alam natin at some point, yung tensile strain ng steel is equal to Fy all over 200,000. Ngayon, yung strain ng steel natin in terms of compression ay i-extend natin hanggang doon sa diagram niya. Ibig sabihin, yung tensile strain ng steel is within compressive block. Wherein this now is equal to Fy all over 200,000 pa rin. Or, kung hindi man nag-yield in terms of Fy, pwede nating sabihin na this is equal to F prime S all over 200,000. Meaning to say, meron ding tensile strength na kino-consider yung steel in terms of compressive strength yung steel natin. So bukod doon sa Fy or Fs, kapag hindi nag-yield, meaning to say, kailangan mo rin kumuha ng compressive strength ng steel just in case hindi nag-yield yung reinforcement mo. Ngayon, mas madaling i-derive yung value ng F prime S as compared doon sa value ng Fx. Bakit? Kung mapapansin natin dito sa figure natin, yung height ng triangle natin or yung height ng strain diagram natin mula dito sa compressive fiber hanggang sa neutral axis is equal to the value of C. Ngayon, yung distance between the compressive fiber and the net compressive strain of steel is equal to D prime. Kung lalakihan natin yung figure natin, pwede nating sabihin na this is 0.003 and this one right here is the net compressive strain of steel. Given that the distances are, meron tayong D prime and the value of C. Ngayon, pwede nating makuha yung value ng F prime S by using ratio and proportion doon sa dalawang figures natin. Since mapapansin natin na may dalawang similar triangles in this particular figure. Now, we can say that 0.003 all over C is equal to F prime S all over 200,000 divided by, ano na ngayon? Ano yung magiging height ng triangle natin? C minus A prime. Now, cross multiplying, we can now have 0.003 multiplied by C minus D is equal to F prime S all over 200,000 multiplied by the value of C. So, multiplying everything by 200,000, so cancel yan. Meaning to say, we can now have 600 multiplied by C minus D is equal to F prime S multiplied by C. Therefore, the value of F prime S now is equal to 600 multiplied by C minus D prime rather. Sorry. So, C minus D prime all over the value of C. Meaning to say, ang kailangan nating hanapin kapag doubly reinforced is or yung na-modify lang is yung value ng A and value ng F prime S. So bukod doon sa value ng Fs, kailangan din nating hanapin yung value ng F prime S. Ngayon, sir, ginagawa natin lahat ng to. Paano natin malalaman kung doubly yung beam? Okay. Paano ulit natin malalaman kung doubly yung beam? Okay. Ngayon, kung analysis ang pag-uusapan natin, so may dalawa tayong approach. Kung analysis ang problem natin, in what way natin pwedeng i-determine kung singly or doubly yung beam? Try to recall kung ano yung ginawa ninyo nung quiz 1. Paano natin dinetermine or paano nyo dinetermine kung singly or doubly yung beam natin? Ano?
Yung sa may Fs po tsaka Fy, kapag po greater yung Fs sa Fy.
Yielding yun. Diba? Kapag yielding yun or hindi. Paano kung singly or doubly?
Yung sa ano po?
Sa?
Hindi ko po sure yung basa kung raw po ba yun?
Raw. Yun. So, ibig
Raw
sabihin,
max.
kailangan natin tingnan yung actual reinforcement ratio. Wherein yung actual reinforcement ratio natin is equal to AS all over BD. Diba? Kapag singly yung case natin, kailangan daw yung raw actual is less than the maximum. Yung raw maximum ulit natin is equal to 3 over 8 multiplied by 0.85 F prime C beta 1 all over Fy if anong case? Yung 3 over
Tension
8
control po.
kapag tension controlled. Kapag yung 3 over 7 ang kinonsider natin, this is in
Transition po.
transition. Yan. Ngayon, same case ulit na kailangan yung raw actual is greater than the minimum. So yung minimum, meron tayong dalawa dyan. Meron tayong 1.4 all over Fy and 0.25 square root of F prime C all over Fy. Ngayon, this is yung case natin kung singly. Paano kung doubly? Ano yung kailangang mag-change dito sa tatlo in order for us to declare na doubly yung beam?
Dapat po yung raw actual mas mataas sa raw max.
Okay. So kapag doubly, yung raw actual natin should be greater than the maximum. Ngayon, ano yung mapapansin natin? Kung yung raw actual natin na AS is greater than the maximum, which is AS max for singly. Ngayon, in terms of analysis, yung AS natin is yung AS na present doon sa beam. Ibig sabihin, yung AS natin earlier is equal to the AS max ng singly na galing dito sa raw max plus yung A prime S natin in terms of compression. Kaya, yung doubly reinforced beam natin ay yung raw actual natin, lumalagpas talaga siya doon sa raw max natin. Kasi, yung raw maximum natin, kumbaga ina-assume natin na yung raw maximum is yung maximum reinforcement kung meron tayong singly reinforced beam. Ngayon, anything na excess doon sa raw maximum would constitute to the compression of steel. Yan yung case natin kung meron tayong analysis na problem. So, what if design naman tayo? Kung in terms of design, ang kino-consider naman natin sa design is yung ultimate moment natin na applied. So meaning to say sa applied, yung mga forces natin is greater than phi mn. Ibig sabihin, yung allowable capacity is less than the applied forces. So ibig sabihin, yung capacity ng concrete natin is not enough to resist yung applied forces natin. So therefore, kailangan nating magdagdag ng reinforcement. So ibig sabihin ng nun, yung MU natin is equal to phi mn1 plus phi mn2. So yung phi mn1 is that of the singly, and yung mn2 is that of the compression. So ano yung mapapansin between analysis and design? So yung magiging deciding factor natin sa analysis and design is, sa analysis, ang magiging deciding factor natin is yung amount of steel reinforcement, whereas sa design, ang magiging deciding factor natin is yung ultimate moment. Kung mapapansin din natin, sa analysis, ang sinosolve natin is yung ultimate moment or yung forces, whereas kapag sa design naman tayo nagsasolve, ang sinosolve natin is yung bakal. Diba? Questions? Before tayo mag-proceed doon sa first problem natin.
Wala pa naman po, sir.
Wala pa naman. So malinaw kung paano ma-determine if singly or doubly.
Yes, sir.
Okay. So proceed tayo dito sa first problem natin. Okay. So sa first problem natin, we need to determine the ultimate moment capacity of the given beam. Given na meron tayong F prime C na 20.7 megapascals and Fy na 276. Okay. So sa doubly reinforced beams, kung mapapansin nyo, meron tayong multi-layered na beam ulit. So sa actual, hindi natin ginagawa yung analysis na ginawa natin last time na yung tinitingnan pa natin kung lahat ng layers na to mag-yield. So in this case, sa problem na to, we need to consider the 6 reinforcements as one system. Meaning to say, kung gagawa tayo ng stress block out of this particular beam, kailangan natin kuhanin yung centroid ng buong reinforcement system na to. Ngayon, syempre, bukod dyan, kailangan din natin i-project yung location ng compressive reinforcement. So, i-check muna natin. So ngayon, yung amount ng reinforcement, hindi pa natin alam kung singly or doubly itong beam natin. So meaning to say, kailangan nating i-assume na singly muna yung beam. Kasi hindi pa natin alam or wala pa tayong idea kung singly ba or doubly yung beam natin. So this beam in question must be assumed as singly. So, ibig sabihin, yung 435 mm na to, And then plus yung 65. Kung mapapansin ninyo, yung 435, hindi pa iyan yung effective depth natin. Bakit? Kung titingnan natin yung amount of reinforcement na 628 mm, meron silang layers na 2 layers na meron tayong 3 reinforcement. Given that they are 60 mm away from each other. Ibig sabihin, yung centroid ng buong 6 na bakal na to is nasaan? Try to recall yung ginawa ninyo before sa engineering mechanics. Kapag nagsasolve tayo ng centroid, ibig sabihin meron tayong 6 na 28 mm na equal yung area separated by a distance. Saan ngayon yung centroid ng lahat ng bakal na to? Yung centroid ng lahat ng bakal na to ay nasa andito sa midpoint, di ba? Ibig sabihin, kung nasa gitna yan, yung effective depth natin ngayon is equal to 435 mm na mula dito sa compressive fiber natin hanggang dito sa centroid ng unang reinforcing layer natin minus ano na?
30.
Yung kalahati ng 60, which is 30. Meaning to say, yung effective depth natin is equal to 405 millimeters. Ngayon, ina-assume pa natin na singly yung beam. So, kailangan natin ngayon kuhanin yung compressive and tensile forces natin. Kasi hindi pa natin alam yung value ng A or yung value ng C. Importante na malaman natin yung value ng A and yung value ng C because this will affect the value of the net tensile strain of steel. Diba? Which is equal to Fs all over 200,000. Ngayon, itong value na to is still the value of C and 0.003. Ngayon, yung value ng compression force or compressive force natin is still equal to 0.85 F prime CAB and yung value ng T is equal to AS F1. Ngayon, dito sa dalawang values na to, pwede nating i-assume kung ano ba yung value ng tension. So, assuming na singly, yung force, yung beam natin, pwede natin kuhanin ngayon yung value ng AS. AS is equal to 6 multiplied by pi over 4 times 28 squared. Ilan ngayon yung value ng AS? So maglabas po kayo ng calculators nyo and solve with me para matapos agad since gusto ko sana pumipindot din ako pero mas okay na interactive tayo. So
3,694.513 po.
8,000?
3,000 po, sir.
3,000, sorry. 3,694.
694.513.
513 square millimeters. Now, assuming na singly, pwede na natin ngayon i-determine kung ano yung tensile force. Ibig sabihin, yung tensile force natin is equal to AS Fy or 3694.513 multiplied by Fy, which is equal to 276. Meron tayong 3694.513 times 276. Meron tayong 1019. 685.588 newtons. So, meron tayo sa system natin na equal to 101.9685.588. Ngayon, kailangan nating alamin yung value ng A to determine the value of C. Meaning to say, we need to assume that the compressive force is also equal to the tensile force. Wherein 0.85 F prime C AB is equal to AS FY. Ngayon, given na meron na tayong AS FY, i-substitute na lang natin yung F prime C and yung base natin. So 0.85 multiplied by F prime C, which is equal to 20.7, multiplied by A, and yung base natin na 250 millimeters is equal to 101.9685.588. Ngayon, simplifying yung equation natin, yung value ng A is equal to 101.9685.588 all over. So, meron tayong 0.85 times 20.7 times 250 is meron tayong 4398.75. Value of A is equal to ilan?
$231.813 po.
Meron tayong 231.813 millimeters. Ngayon, to solve for C, alam natin na yung value ng A is equal to beta 1 C. Yung value ng beta 1 natin is equal to ilan? Given na ang F prime C natin is 20.7.
0.85 po.
0.85 because F prime C natin is less than 28 megapascals. Value of C is equal to 231.813 divided by 0.85 or equal to ilan?
272.721.
272.271. Ay, 721 rather. 272.721 millimeters. Okay. Ngayon, upon solving for the value of C, assuming that this is singly reinforced, paano natin hinahanap ngayon yung value ng Fs? To solve for the value of Fs in terms of singly is also the same as that of the doubly reinforced beam. Meaning to say, Fs is equal to 600 multiplied by the effective depth minus C all over C. Or equal to 600 multiplied by the effective depth, which is equal to 405 minus 272.721
Wala pala ako.
over 272.72.
Friction tape meron na sa bahay. Sa bahay.
Fs now is equal to
291.020.
ilan? 272.271.
291.02 po.
291.02.
02.
megapascals. Okay. Ngayon, if meron tayong 292.02 megapascals na value ng Fs, ano yung value ng Fy natin? Ang value ng Fy natin is 276. So Fs is still greater than Fy. Therefore, this is
Yield.
Pero, ano yung mapapansin natin? Yung Fs natin is less than 1,000. Therefore, anong case natin?
Transition po.
Transition. Ngayon, kung in transition tayo, meaning to say, yung strength reduction factor natin, hindi muna natin kukuhanin kasi ina-assume pa natin na singly reinforced yung beam natin. Diba? Hindi pa tayo nagsasolve ng ultimate moment. So ano yung importante na sa atin in terms of transition? Ang kailangan natin munang malaman in terms of transition is yung raw maximum. Wherein yung raw maximum now is equal to 3/7 multiplied by 0.85 F prime C beta 1 all over Fy. So, meron tayong 3/7 multiplied by 0.85 times 20.7 times beta 1 na 0.85 all over Fy na 276. Raw maximum is equal to ilan?
0.023 po.
0.023. Ngayon, dito sa 0.023 na raw maximum, we need to compare yung raw actual. So, in this time, we need to determine if singly. Now, to determine if this is singly, we need to determine or we need to find the raw actual. Raw actual is equal to AS all over BD or equal to, ang AS daw natin earlier is 3694.513 all over BD, which is equal to 250 multiplied by the effective depth of 405. Raw actual is equal to 3694.513 divided by 250 times 405. So meron tayong 0.0364. Ano yung mapapansin ngayon? Yung raw actual is greater than the maximum. Therefore, doubly. Ano yung ibig sabihin kung doubly? Yung beam natin. Ibig sabihin lang yan, lahat ng sinolve natin dito kanina is hindi tama. Ibig sabihin lang, yung value ng A and yung value ng C and yung value ng Fs are all wrong. Kasi nag-assume tayo dito kanina na singly yung beam natin. And na-prove natin na doubly pala siya. So meaning to say, kailangan nating ulitin yung pagsosolve ng value ng A and C and Fs. And dagdag doon na bukod sa magsosolve tayo ng Fs, kailangan na natin ngayon mag-solve ng F prime S. So paano na ngayon yung gagawin? So now, kailangan na nating hanapin yung pag-yield ng compressive and tensile reinforcement. So paano natin hahanapin kung yielding or not? Ang paghahanap natin kung yielding or not is kailangan na natin ngayong idamay lahat ng reinforcements na involved. So meron daw tayong AS kanina na equal to 3694.513 and hindi pa natin alam kung ano yung value ng A'(S). Ang A'(S) daw natin, according to the problem, is dalawang 28 mm. Meaning to say, we need to find the area for this particular steel reinforcement. Two times pi over 4 times 28 squared is equal to that. Meron tayong 392 pi or 1231.504 square millimeters. So itabi muna natin yan. Ngayon, bukod dyan, kailangan na natin ngayon i-consider both tensile and compressive reinforcement. Aside from the fact that we have a compressive block na intended for the maximum steel reinforcement. Ngayon, meron tayong AS1 and AS2 as considered na ito ay doubly reinforced. Ibig sabihin, bukod doon sa compression ng concrete, meron na rin tayong compression ng steel na dapat nating tingnan. So meron tayong compression ng concrete na equal to 0.85 F'C AB and compression ng steel na equal to A'S Fy. Assuming na yielding yung compression ng steel natin. Same time, meron tayong T1 na equal to AS1 Fy and T2 na equal to AS2 Fy. Ngayon, madali nating makukuha yung A'S Fy. Pero hindi natin alam kung ano pa yung value ng compression ng concrete. Bakit? Hindi pa natin alam yung value ng compression of concrete because as a system, kailangan nating i-assume na yung summation ng compression is also equal to the summation of all the tensile forces involved. Meaning to say, meron tayong 0.85 F'C AB plus A'S Fy is equal to As Fy. Taking note na yung tension natin is equal to T1 plus T2 wherein As is equal to As1 plus As2. Ngayon, mas madali nating makukuha yung value ng A. Diba? Kanina, meron na tayong na-solve na value for ASFY. So, ibig sabihin, yun na rin yung pupwede nating gamitin, which is equal to 1019685.588. So, 1019685.588. Tama ba? Yeah. Because I can only memorize such. Yeah. Ngayon, yung A hindi pa natin alam because kanina nag-assume tayo na this is singly. Pero in this case, since nalaman na natin na this is doubly reinforced, mag-iiba na ngayon yun yung value ng A. Wherein 0.85 multiplied by F'C na 20.7 multiplied by A And yung base na 250, ano ba yan? Ano pa yung space? Sorry. Wait lang. Ayusin natin yung space para iisang system na lang siya. Or isang base equation na lang. So, meron tayong 0.85 multiplied by 20.7 multiplied by A and 250 plus AS na 1231.504 multiplied by FY na 276. Tama ba? Yan, 276 is equal to total ng tensile forces natin. So, further simplifying this equation, meron tayong 0.85 times 20.7 times 250 is meron tayong 4398 ulit. So, 4398.75 A plus yung 12, hindi, i-ano na natin, i-transpose na rin natin. So, this is equal to 101,9685.588 minus yung 1231.504 times 276, which is equal to 339,895.104. Value of A is minus 101,9685.588. Meron tayong 679. Sige, iabang mo yung answer. 679,790.484 all over 4398.75. Value of A is equal to ilan?
154.542.
154.542
542.
mm. Ngayon, ano yung previous answer natin kanina sa A? Kung mapapansin natin, yung previous answer natin kanina sa A is 231.813 millimeters. Higit na mas malaki compared dito sa actual pala na value ng A, which is just equal to 154.542. Diba? So, malaking difference. Ibig sabihin lang nun ulit, yung value ng C will also change. Given that beta 1 is equal to 0.85 as solved earlier, value of C is equal to 154.542 all over 0.85 or equal to ilan?
181.814.
181.814
814.
millimeters. Ngayon, bukod dito sa amount ng reinforcement or kung papansin nyo, kinompare natin yung compression and tension forces, kailangan din natin ngayon hanapin yung lahat ng net tensile strain or net compressive strain or lahat ng forces na involved or stresses. Now, relating yung stresses, kanina, alam natin na same time meron tayong neutral axis wherein the stress distribution is equal to 0. Kailangan na natin i-correlate yung strain diagram for this particular setup. Ngayon, given na ang maximum ulit is still 0.003 for concrete, pero kailangan natin kuhanin kung ano yung F'S and ano yung Fx. Alam natin na ang value of C is equal to 181.814. Pero hindi pa natin alam ngayon kung ano yung distance between compressive fiber and compressive reinforcement. Ano yung value ng D prime natin? Punta ulit tayo dito sa figure. Ang value ng D prime natin based on observation is equal to ilan?
65.
65 millimeters. Okay. So, upon determining that D prime is equal to 65 millimeters, pwede na nating mahanap yung both Fs and F prime S. Knowing that the value of the effective depth is equal to 405 millimeters. Ngayon, meron tayong dalawang equation ulit na present. Meron tayong Fs is equal to 600 multiplied by D minus C all over C. So, pwede na nating mahanap agad yung value ng Fs dito. Na hindi na natin kailangang i-prove kung singly or doubly kasi na-prove na natin earlier. Kailangan na lang natin hanapin if yielding or kung anong reinforcement condition para mahanap natin yung strength reduction factor. Now, we have 600 multiplied by 405 minus value of C is equal to 181.814 all over 181.814. Fs is equal to ilan?
736.531.
736.531 megapascal. Okay. Mapapansin na higit na malaki yung value ng Fs ngayon compared kanina. Ang nakuha natin kanina is nasa bingit na ng kamatayan because malapit na masyado sa Fy. Yung Fy natin is 276, di ba? Yan. So instead na 291.02 yung present na Fs, ang actual pala talaga kung doubly reinforced yung beam natin is equal to 736. Therefore, yielding, di ba? So na-prove natin na yielding yung bakal natin. Ano pa yung isang na-prove natin na tama? Ano yung assumption natin doon sa reinforcement condition kanina? Aside from doubly, this is still in
Transition.
transition. Ngayon, since this is in transition, pwede na natin agad makuha yung value ng strength reduction factor. So this time, pwede na natin kuhanin kasi this is already the actual setup. So strength reduction factor, since this is in transition, is equal to 0.65 plus 0.25 multiplied by Fs minus Fy all over 1,000 minus F1. So meron tayong 0.65 plus 0.25 multiplied by Fs na 736.531 minus 276 all over 1,000 minus 276. Strength reduction factor is now equal to ilan?
0.809.
0.809. Ngayon, after solving na yielding yung Fs, kailangan nating hanapin kung yielding din ba yung F prime S. Okay? So, formula for F prime S as derived earlier is equal to 600 multiplied by C minus D prime all over value of C. So meron tayong 600 multiplied by 181.814 minus d prime, which is equal to 65 all over 181.814. Value of f prime is
385.495.
385.495.
495.
Since yung f prime s natin is greater than fy, therefore, yielding ngayon yung bakal natin. Okay. Sir, kailangan pa bang malaman kung ano yung reinforcement condition sa f prime s? Hindi na. Kasi tinitingnan lang natin yung reinforcement condition kung in transition, compression, or tension control, kung tensile reinforcement ang kino-consider natin. Kasi alam natin na yung compressive reinforcement natin is solely made for compression. Okay, kumbaga parang yung f prime s or yung amount ng i-rephrase ko. Yung amount ng compressive reinforcement natin is not required. Kumbaga parang may special cases lang na kailangan natin ng compressive reinforcement like in this particular problem. Kasi yung tensile reinforcement required talaga yan as is, 'di ba? So dito kapag f prime s ang compressive reinforcement ang kino-consider natin, ang dapat lang nating tingnan ay kung yielding ba or hindi. Okay? Sir, baka paano po kung not yielding yung f prime s? And then from this moment on, maghahanap ka ulit ng bagong value ng c in terms of f prime s. So, yun yung next problem natin para lang malaman ninyo na yun yung next problem natin. Ngayon, kung mapapansin din ninyo, paulit-ulit yung ginagawa natin. Bakit? Paulit-ulit yung ginagawa natin dito sa particular problem ng concrete design because iterative lahat ng terms natin. Na hanggat hindi pa nasa-satisfy lahat ng assumptions natin, hindi tayo titigil na sa pagkuha ng tamang answer. Ngayon, since parehas na yielding na yung Fs and F prime S, pwede na natin ngayon makuha yung ultimate moment. So we need to now determine the ultimate moment mu. Alam natin na yung ultimate moment is equal to Vmn1 plus Vmn2. Ngayon, base dito sa figure kanina, mayroon din tayong amount ng moment arms na dapat tingnan. Ngayon, yung AS1 and AS2, kailangan pa ba nating hanapin? Itong AS1, sa itong AS2, kailangan pa ba natin silang hanapin para makuha yung moment?
Pwede pong hindi na. Pwede pong gamitin yung compression.
Okay. Mas okay na gamitin yung compression because alam na natin yung value ng A and alam na natin yung value ng A prime S. So there's no need to find AS1 and AS2 not unless design yung problem natin. Okay. I-simplify muna natin itong mga terms na to. So meron tayong compression ng concrete na equal to 0.85 multiplied by 20.7 multiplied by A na nakuha natin earlier which is equal to 154.542 multiplied by base na 250. Or kung para mas maintindihan since medyo kain tayo sa space dito, pwede naman nating i-derive. So, yung ultimate moment natin is equal to mn1, Tmn1 plus Vmn2, wherein yung mn1 natin is equal to the compression ng concrete natin, which is 0.85 F prime C AB multiplied by the moment arm, which is equal to D minus A over 2 plus yung compression ng steel. So, mapapansin, meron tayong compression ng concrete plus yung compression ng steel. So, meron ulit tayong value ng phi multiplied by A prime S Fy multiplied by D minus D prime. Okay. So, substituting lahat ng values na yan, pwede ka agad makakuha ng simplified version nito. So, pwede nating sabihin na this is equal to phi multiplied by. So, meron tayong 0.85 times F prime C na 20.7 times A na equal to 154.542 times 250 multiplied by D na 405 minus 154.542 all over 2. Ano ulit yung value ng phi natin? Teka lang, ang value ng phi natin is equal to 0.809. So, plus 0.809 multiplied by A prime S. Nakuha natin yung A prime S natin earlier na equal to 1231.504 multiplied by Fy, which is equal to 276 multiplied by the moment arm, which is equal to 405 minus D prime, which is equal to 65. So further simplifying our equation, meron tayong 0.809 times 0.85 times 20.7 times 154.542 times 250 times yung moment arm natin na 405 minus 154.542 over 2. Yung first term natin is equal to 180,235,029.8 plus. Anyone who solved the second term? Pwede pong sumagot. 0.809 times 1231.504 times 276 times 405 minus 65. Second term,
9349
9349
1547
1547.31
.31 po.
So, adding both, meron tayong ultimate moment na equal to that.
2737
2737
26577
26577.1
0.1. Ayan na po, 0.100.
Okay. So, 0.1 unit is in Newton millimeters. Therefore, meron tayong MU rin na equal to 273.727 kilonewton meter. So, yan yung final answer natin for problem number 1. Question?
Sir, ako po, sir.
Okay.
Kung ano po, kung ang gusto ko pong gamitin yung AS sub 1 and AS sub 2 po, paano ko po siya makukuha, sir?
Okay. Kung kukunin mo yung AS1 saka AS2, ang gagawin mo is ganito. Teka, yan na natin ha. Pero this is unnecessary, pero i-explain ko na rin. So, ilagay ko lang na na not necessary. Okay. So, to solve for AS1 and AS2, yung AS2 medyo madali. Alam natin na yung AS2 is equal to A prime S. Diba? Ngayon, para mahanap yung AS1, alam natin na yung total amount of steel reinforcement is equal to AS1 plus AS2. Ibig sabihin, yung AS is equal to AS1 plus A prime S. Therefore, yung AS1 natin is just equal to the amount of area ng steel reinforcement minus yung compressive reinforcement. Ibig sabihin, kung yung AS natin kanina is equal to, titignan ko muna ulit, meron tayong A prime S na 1231.504. And then yung buong AS natin is 3694.513. AS1 now is equal to ilan? 3694.513 minus 123.
24
Ilan? 24?
2463.009 po.
So meron tayong 2463.009 square millimeters. Pwede mong gawin, kung kinuha mo yung AS1, you can now actually solve for phi mn1 din. Wherein phi mn1 is equal to AS1 Fy multiplied by D minus A over 2. Since alam natin na yung C, compression ng concrete is equal to tension ng 1. So meron tayong 2463.009 multiplied by Fy na 276 multiplied by D na 405 minus A over 2. A is equal to 154.542. Ay, MN1 lang pala to. So, kung may fee, idagdag po natin yung 0.809. Tama po ba? Ayan. Fee MN1 is equal to, itry natin kung mag-i-equal or sigurado to may discrepancy. 2463.009 times 276 times 0.809 times yung moment arm na 405 minus 154.542 over 2. 18023. Tingnan natin ha. Ang sagot dito initially is 180234727.9. Ang discrepancy niya is 1235. So dito mag-start yung discrepancy. So 5029.8. Ang dito ay 4727.9. Ano yung mapapansin? Mas malaki yung value na makukuha natin if yung compressive fiber ang kukunin, yung compressive block natin sa concrete yung i-consider natin as compared doon sa T1. Sir, bakit? Kasi yung A as 1 natin is kinonsider na natin as buo. Kumbaga kanina, nag-round off na tayo dito sa 3694 and doon sa 1231. Hindi natin kinonsider na pwede namang 4 na 28 na lang na bakal yung ano, di ba? Kasi dito, kanina, kung mapapansin nyo, yung 3694 ay 6 na 28. Tapos yung 1231 is just 228 mm. Di ba? Therefore, alam natin na yung AS1 is meron tayong 4 na 28. Nanggaling yung discrepancy na yan siguro doon sa pag-determine natin or pag-simplify natin ng pi. Nakukuha? So, okay lang naman din. Pwede naman ako magko-consider naman ako na baka mamaya kasi kapag nag-quiz yan, yung ginamit nyo yung AS1, which is totally fine. May mga probable answers naman for that. Nakuha?
Yes po, sir. Thank you po.
Okay. Questions pa? Wala
Sir,
na?
question po.
Oh, sige.
Halimbawa po sir, magsosolve po kami ng analysis problem. Dadaanan pa po ba namin yung i-determine kung singly yung ano po, yung problem po bago
Of
po
course.
kami mag-double?
Of course.
Okay
So,
po.
paano kung ganito yan? May mga problems, i-explain ko lang ngayon sa board exam na. May mga problems sa board exam na may given na compressive reinforcement. Pero all along pala, singly reinforced siya. Baka kasi mamaya, dire-diretso kayo sa pagsosolve ng doubly reinforced siya kaagad kahit singly pala siya. Yun. May mga twist na ganun sa mga quizzes natin and sa mga exams na paparating, kaya might as well i-check lahat. Yun. Questions pa? Wala na?
Wala na po, sir.
Wala. Okay. So, itong problem 2 gawin nating home. Ay, hindi. Yung problem 2 kasi ay nasa module eh. Pero, might as well siguro explain ko na rin today. Ipaho-homework ko sana eh. Kaso naisip ko na nasa module nga pala. Ba't ako magpapa-homework ng nasa module? So, ayan. I-ano natin yung problem 2. Answer natin yung problem 2. Okay. So, sa second problem, meron tayong given na A'(S) na 220 mm and AS na 4 na 28. So kung mapapansin nyo, directly, magkaiba yung bar diameter. Sir, madalas po bang mangyari na magkaiba ang bar diameter sa site? Hindi. Kasi sa actual, talagang kumbaga parang pinagmamatch mo na yung reinforcement. Not unless talagang no choice ka kung hindi mag-separate na reinforcing bar, saka ka palang gagawa ng ganitong klaseng design. Mahirap siyang gawin ang actual kasi baga parang under time pressure ka rin sa actual. Baga parang nagbibit ka ng deadline or nagbibit ka ng schedule na matapos yung project mo. Kumbaga yung mga workers, hindi na sila or wala na silang time para tingnan kung ano bang diameter pa yung ilalagay nila. So mas okay na uniform na. Pero syempre sa stirrups, ibang usapan yun. Or ibang usapan rin kapag column. Kailangan mo lang gawin na uniform yung bakal para sa beam, uniform yung bakal para sa column, uniform yung bakal para sa stirrups and ties. Yun. Okay. So in this particular problem ulit, magkaiba yung value ng AS and A'S in terms of diameter. Kaya kailangan natin talagang hanapin kung ano ba yung actual values. So, A prime S is equal to 2 multiplied by pi over 4 times 20 squared. And yung AS natin is equal to 4 times pi over 4 times 28 squared. Further computing, meron tayong 2 times 0.55 times 20 squared, which is equal to 628.318. Square millimeters. And yung AS natin na 4 times 0.25 pi times 28 squared or 2463.008. At 009 rather. Ayun. Sa first step ulit ng pag-assume natin ng mga equations, kailangan muna natin i-assume na singly. Para ma-assume natin na singly, ano yung dapat nating gawin? Kailangan nating tingnan kung ano yung value ng C para mahanap natin yung Fs. Yung Fs ngayon yung mag-lead sa atin kung ano ba yung maximum value ng reinforcing ratio. Ngayon, solving for compressive force, meron tayong 0.85 F prime C AB na equal to 0.85 multiplied by 27.6 times A times 360. Amount of compressive force is equal to 0.85 times 27.6 times 360 or 8445.68. Now, bukod doon sa compressive force, kailangan nating hanapin ngayon yung tensile force. Tensile force is just equal to ASFY or 2463.009 multiplied by Fy na equal to 414. Tension, so meron tayong 2463.009 times 414 na 1019 685.726. Ngayon, if we assume that this is singly, we know that the compressive force is equal to the tensile force then. So 8445.6 A is equal to 101,9685.726. A is equal to
120.736.
120.736 millimeters. Now, further assuming na yung value ng beta 1 is equal to ilan? If yung compressive strength natin is 27.6, 0.85 pa rin yan. Since F prime C is less than 28. Value of C is equal to 120.736 all over 0.85. 736 divided by 0.85 or equal to 142.042. Ngayon, after solving for C, we need to determine the value of Fs, wherein Fs is equal to 600 multiplied by D minus C all over C are equal to 600 multiplied by yung effective depth natin. Okay. In this case, ano yung value ng effective depth natin? So, meron tayong 690 minus 75 wherein B is equal to 615 mm. So, meron tayong 615 minus value of C na 142.042 all over C ulit. Ilan ngayon yung value ng Fx?
1997.823.
1997.8 megapascal. Meaning to say, Fs is greater than Fy yielding ngayon yung bakal natin. Ano pa yung na-prove natin? Yung Fs natin is greater than 1,000. Therefore,
Tension controlled.
tension control. Kung tension control yan, alam natin ngayon na yung maximum amount of reinforcement natin is equal to 3/8 multiplied by 0.85 F prime C beta 1 all over F1. So meron tayong 3/8 multiplied by 0.85 times F prime C natin ulit ay 27.6 times 0.85 all over Fy na equal to 414. Raw maximum is equal to meron tayong 0.0180. 0181 rather. Yan. Ngayon, since meron na tayong raw maximum, pwede natin kuhanin ngayon yung raw actual. Raw actual is equal to AS all over BD. Or, yung AS natin is 2463.009. All over yung B natin, base natin is 360 multiplied by effective depth of 615.
0.0111.
0.0111. Okay. Ito yung na-answer ko, nasagot tayo na tanong kanina na ano yung mapapansin nyo ngayon? Yung raw actual is ano?
Greater than maximum.
Greater ba siya sa maximum?
Less than po, less than.
Siya doon sa maximum.
Less than, sorry.
Yes, di ba? Therefore, ano yung beam natin?
Singly.
Singly yung beam natin. So, hindi ibig sabihin na may compressive reinforcement na tayo, doubly reinforced agad siya. So, kailangan mo munang i-assume na singly siya before ka mag-prove kung kailangan mo na bang gamitin yung compressive reinforcement. Okay. So, since singly reinforced yung beam natin, therefore, pwede na nating malaman ngayon kung ano yung value ng MU. Now, to determine MU, ibig sabihin, itong system na to, yung gagamitin ko. 'Di ba? Hindi ko na ngayon kailangan yung value ng A'(S) kasi singly reinforced yung beam ko. Kailangan ko palang i-revise yung module. Diyos ko, ang dami kong ginawa doon. Pero, ganito lang talaga siya kasimple. Ngayon, isang stress block lang yung dapat natin gamitin. Therefore, yung Z natin is just equal to D minus A over 2. Since nakakuha na tayo ng tensile force kanina, ito na lang na tension yung gamitin natin. Compared na magsasolve pa tayo ng compressive since equal lang naman sila eh. So, ibig sabihin, MU is equal to phi MN. Since tension controlled yung beam natin, yung strength reduction factor phi is equal to 0.9. Now, pwede nating sabihin na this is either phi multiplied by either compression or tension multiplied by D minus A over 2. So, further solving, meron tayo equal to 0.9 multiplied by C or T. Meron na tayong magnitude kanina which is equal to 1019685.726. Sorry, I can only memorize much. 1019685.726. Multiplied by D, which is 615, minus A over 2. Ang amount natin for the value of A is 120.736. All over. Ultimate moment is equal to ilan?
508
508
995
995
300.2
2 Newton millimeters. Or meron tayong 508.995 kilonewton meter. So yan na ngayon yung problem number 2. Baga hindi mo na kailangang tingnan kung yielding or not yung F'S kasi hindi siya necessary. Okay, so doon sa module, baga mapapansin niyo yung difference between the module and itong diniscuss ko, mainly because doon sa module, kailangan nating ipakita lahat ng possibilities. Pero answers-wise, ang pinakaunang step talaga na dapat mong gawin is i-assume mo na singly reinforced yung beam mo. Questions? Clarifications? Or violent reactions?
Wala naman po ata, sir.
Wala? Okay. So, kung wala kayong tanong, answer yung homework doon sa last page ng module. Homework 1, yung problem na analysis. So, yung design, wag nyo munang galawin. Ang deadline ng homework would be on next week din ng Tuesday. Okay, announcements. Yung mga announcements natin, may schedule tayo ng quiz 2. Yung quiz 2 will be on Thursday. April 29. Three to 5 p.m. pa rin. And next week, yung midterm exam. Midterm exam will be on Monday. Monday ay May 3. Tama? May 3, 2021. Ang oras natin nun ay 3 to 6 p.m. Pero pag-iisipan ko pa yung midterm exam on Monday kung 3 to 6 p.m. ba or 12 noon to 12 midnight. Depende sa intensity ng magagawa kong exam. Wala naman siguro may pasok ng Monday because ang school days lang ay Tuesday to Friday. Pero itong Monday, kailangan talaga natin na mag-midterm exam kasi kumbaga sa schedule natin, hindi ko na-anticipate na yung Holy Week natin and yung first week ng enrollment ay vacant. So medyo lagging behind tayo ng 2 weeks. Questions pa?
Sir, yung sa quiz 2 po, mula po ba sa may design po sa may singly yung coverage? Hanggang dito po sa ngayon.
Ang quiz 2 natin ay analysis lang. Huwag muna tayo mag-design.
Okay po, thank you po.
Analysis lang ng either singly or doubly. So, yan. May hint na kayo kung ano yung gagawin since dito lang naman magkakatalo. Pero, okay. Base sa pagkaka-check ko ng quiz 1 last time, ang dapat nyong aralin is shear and moment diagram talaga. So, try to answer problems regarding shear and moment diagram. Kasi basically ito, napansin ko naman sa mga quizzes nyo, naintindihan nyo naman yung lesson. Naintindihan nyo tong concept ng beams. Ang ano lang doon is kung paano yung approach ninyo in terms of shear and moment diagram para makuha yung ultimate load na po pwedeng i-apply doon sa beam. So, yun lang yung nakita kong problem. Yeah. So, try to answer yung mga problems regarding shear and moment diagram tapos mag-practice na rin kayo ng mga probable na lumabas. Baga parang hanapin kung ano yung dead load na kailangan o kaya yung live load in terms of ganitong klaseng factors and stuff. Yun. So, ibig sabihin, yung quiz 2, ang quiz 2 natin, ang coverage ay doubly. Sige, para lang malinaw. So, doubly analysis. Ang midterm exam ay singly and doubly. Siguro ito ay design. Yan. Yan na yung quiz 2 sa midterm. Yung doubly, i-asynchronous ko na design. Since medyo na tayo sa time. Salat tayo sa time. Pero ito may probability na mag-iba. Yeah. Question?
Wala na po siguro, sir.
Wala na. Okay. So, kung wala na kayong questions, yung lecture na to will be uploaded sa YouTube ulit and then I will be sending this sketchpad para sa reference ninyo. Okay, so kung wala na kayong tanong, let's declare this class dismissed and ingat po tayo parate. Thank you so much.
Thank you po, sir.
Thank you po.
Salamat po.
Thank you po.
Thank you po,
sir.
sir.
Opo.